In this video, we will learn how to calculate the parameters of motion for a freely falling body. Let us consider an object as shown in this figure. It is located at a height h above the surface. It is initially rest, so its initial velocity u is 0. When this object is released, it will start falling down in free fall. Now remember that we have previously seen the value of g is taken as constant for heights which are negligible when compared to the radius of the Earth. So this body is considered to be experiencing a constant acceleration g, which is usually 9.8 meters per square second. Because acceleration is constant, and the body falls down in a straight line, all the three equations of motion we have seen previously can be applied to calculate all the parameters of motion for this body. So if an object is at rest is released from a height h above the surface, its initial velocity u is 0, its final velocity, that is the velocity with which the object hits the surface, is taken as v. The time taken for the object to reach ground is represented as t, and the displacement is the height h. This is the initial position and this is the final position. The shortest distance between initial and final positions is clearly h. Let us first use the equation s is equal to ut plus half at squared. We have to substitute the appropriate terms in this. S is h. So h is equal to u is 0 into time is t plus acceleration is g, into again time is t, so t squared by 2. 0 into t is 0. So what we get from this is h is equal to half gt squared. This is the relation between height and time. Next, let us use v is equal to u plus at. U is 0 and a is g. So that gives us v is equal to gt. This is the relation between final velocity and the time taken to reach ground. Next, let us use v squared minus u squared is equal to 2as. U is 0, a is g, and s is h, which will give us v squared is equal to 2gh. If we apply square root on both sides, we get v is equal to root 2gh. This is the relation between the height and the final velocity. Since acceleration is a vector, it is taken as positive when it acts in the direction of motion and negative when it acts in the opposite direction of motion. If we observe this figure, in the first case, the ball is moving up, but gravitational acceleration is acting downwards, which is opposite to the direction of motion of the ball. So the acceleration is taken to be minus 9.8 meters per square second. In the second case, the ball is moving down and the gravitational acceleration is also acting downwards, in the same direction as the motion. So the acceleration is taken to be plus 9.8 meters per square second. When we throw a stone vertically upwards, the gravitational force tries to pull it down and reduces its velocity. Due to this constant downward pull, the velocity becomes 0 after a while. This point at which the velocity becomes 0 is the maximum height the stone can go up to. But the gravitational pull continues to be exerted and the stone starts moving vertically downward. So the stone, which was initially moving upwards, gradually slows down, reaches a point where its speed becomes 0 and then comes down. And as it comes down, its speed keeps increasing because of the positive acceleration provided by gravitational force. Let us look at an example problem for free fall now. An iron ball of mass 3 kilograms is released from a height of 125 meters and falls freely to the ground. Assuming that the value of g is 10 meters per square second, calculate the time taken by the ball to reach the ground, the velocity of the ball on reaching the ground, and the height of the ball at half the time it takes to reach the ground. As always, we will start by making a figure. So we will take a ball of 3 kilograms at a height of 125 meters above the ground. Next, let us list down all the quantities given to us. The first thing mentioned in the question is mass, which is equal to 3 kilograms. Now this is absolutely useless information for us, because if you recollect the equations of motion, none of them have the term for mass. So we don't need to do anything with this. Next, we are given the height from which the ball is released. So we will write that down as h is equal to 125 meters. And then we have acceleration due to gravity, which is g is equal to 10 meters per square second. Always be careful with the value of g you are using. Always check if the question is specifying you to use a particular value of g. If the question doesn't specify any value, then you can take g to be 9.8 meters per square second by default. Next, let us start writing some things given to us under different names. As we have seen in the previous slide, the displacement of the ball is equal to the height from which it is released. Whenever in a question they say that the object is released and then don't give any speed or velocity after the word released, that means the initial velocity is 0. So in the first part, they are asking us to find time. Which equation of motion has the relation between displacement, initial velocity, and time? It is S is equal ut plus half at squared. So we will substitute the values in this. S is 125 meters. U is 0 meters per second. Acceleration is 10 meters per square second. 0 into t is 0, so we have 125 meters is equal to half into 10 meters per square second into t squared. So then we have 10 divided by 2 is 5 meters per square second into t square is equal to 125 meters. We will interchange the LHS and the RHS so that we can have the variable on LHS. Next, we can send the 5 meters per square second to the right-hand side. That gives us t squared is equal to 125 meters, divided by 5 meters per square second. We can cancel the meter in numerator and denominator. Now this is a very important concept from fractions. Whenever you have fractions within fractions, you keep the numerator on top as it is. So the numerator on top n1 is written as it, and then an into sign is put next to that. Now this is the important part. The fraction in the denominator, we have to write its reciprocal beside the into mark. 125 by 5 is 25, and the second square term comes into numerator by simplifying the fraction. Next, if we apply square root on both sides, we get t is equal to 5 seconds. Moving on to the second part of the question, we are asked to find the final velocity. We can use any of the other two equations to find the final velocity. I am choosing to use v is equal to u plus at because it will be simpler for calculation. So if we substitute the values in this, u is 0. Acceleration is 10 meters per square second. And time, we have just found this out to be 5 seconds. 10 into 5 is 50, so we have v is equal to 50 meters per second. Next, in the third question, we need to find the height where the ball is at half the time it takes to reach the surface. We can represent this new time as t dash. So t dash is half of t, which was the time taken for the ball to reach the surface. We calculated t to be 5 seconds, so t dash is 5 by 2, which is 2.5 seconds. Let us take the height at which the ball is located at the time t dash to be h dash. Let us represent the displacement of the ball to be s. Now let us understand these quantities on the figure. We can see that the ball is at 125 meters at t is equal to 0 seconds. Takes 5 seconds to reach ground. So at 2.5 seconds, it will be somewhere in the air near the ground. Now this is the displacement of the ball as it falls down. So this is the s. But this is not what we need to find. We need to find the height from the ground. So this is h dash. But we don't have any ready-made equations to find this height from the ground. But we do have equations to find the displacement s. So the idea here is quite simple. First, we will find the displacement, and then if we remove the displacement from the total height, what we are left with will be h dash, the height from the ground. To find s, we can use the equation s is equal to ut plus half at squared. But in this scenario, we are only taking half the time, so we can rewrite this equation as s is equal to ut dash plus half at dash squared. Now we can substitute all the values and find s. We know u is 0, half time t dash is 2.5 seconds, acceleration is 10 meters per square second, finally again t dash is 2.5 seconds, which will be inside a whole square. Now 0 into 2.5 is 0, and then 10 divided by 2 is 5. So we are left with s is equal to 5 meters per square second into 2.5 squared is 6.25 seconds squared. We can multiply 5 and 6.25. So we get s is equal to 31.25 meters. The square second in numerator and denominator get cancelled out. Now, in order to find the h dash, we will subtract this s from 125 meters. So h dash is equal to 125 meters minus 31.25 meters. That gives us the value of h dash to be 93.75 meters. So the ball is located at a height of 93.75 meters at halftime. Next, let us look at another example. A tennis ball is thrown up and reaches a height of 4.05 meters before coming down. What was its initial velocity? How much total time will it take to come down? As always, let us start by drawing a figure to understand the question better. We have a tennis ball here which was initially on ground. When the ball is thrown up, the ball goes to a height of 4.05 meters. Now let's write down all the quantities given to us. First, we are given the maximum height reached to be 4.05 meters. Then we have the value of g to be 10 meters per square second. Now, as we have seen previously, when an object is thrown upwards at its maximum height, it will stop before coming down. So we know that the velocity at the maximum height is 0. We can take that as the final position and write the final velocity as 0 meters per second. Next, we can write that displacement, the initial position is ground and the final position is the maximum height. So displacement is also h is equal to 4.05 meters. And then for acceleration, we need to be careful here. The ball is going upwards, but the acceleration due to gravity is always downwards. Since the acceleration is in the opposite direction, we will take the value of acceleration to be minus 10 meters per square second. The first question for us is to find the initial velocity with which the ball was thrown up, which we can consider to be u. Since we know v, s, a, and we need u, we will use the equation v squared minus u squared is equal to 2as. So let us substitute the values in this. We have seen that v is 0. Next, a is minus 10 meters per square second, and displacement is 4.05 meters. 0 squared is 0. So what we have is minus u squared is equal to minus 81 meters squared by second squared. Minuses on both sides get cancelled, and then we get u squared is equal to 81 meters squared by second squared. If we apply square root on both sides, we get u is equal to 9 meters per second. So the ball was thrown up with an initial velocity of 9 meters per second. This is only the first question. There was a second question which asked us to calculate the total time taken by the ball to come down. This is also called as time of flight. The calculation of time of flight is something we have to be very careful about. The complete journey of the ball can be divided into two parts. First is the part where the ball is thrown up with 9 meters per second velocity, and it keeps going up until it stops at 4.05 meters. In the second part, the ball starts coming down from 4.05 meters until it reaches the ground. Remember that the ball is momentarily at rest before coming down, so initial velocity in part 2 will be 0. The reason why it is important to break down the journey of the ball into two parts is because of the direction of acceleration. In the first part, the ball is moving upwards, but the acceleration due to gravity is always downwards. So in the first case, the acceleration of the ball is minus 10 meters per square second. In the second part, the ball is coming downwards and the acceleration due to gravity is also downwards. So the acceleration of the ball is plus 10 meters per square second. Let us first take only the part 1 of the ball's journey. So in the first part, the ball is thrown up with initial velocity 9 meters per second, and when it reaches the maximum height, its velocity will be 0. As we have seen just now, the direction of g is downwards, but the ball is moving upwards, so the acceleration of the ball is minus 10 meters per square second. Let us assume that the time in the first part of the journey is t1, and we need to find out the value of t1. So we have the values of u, v, a, and we need to find the value of t. So we will use the equation v is equal to u plus a t. So we can plug in the values v as 0, u as 9 meters per second, a as minus 10 meters per square second, and finally t as t1, and solve this equation. If we keep only the 9 meters per second on the right side and send the other term to the left side, we get 10 meters per square second into t1 is equal to 9 meters per second. We can send the 10 meters per square second to the other side, which will give us t1 is equal to 9 meters per second divided by 10 meters per square second, which is equal to 0.9 seconds. So the ball takes 0.9 seconds to go up until 4.05 meters. But this only half of the journey. We still need to find the time taken in the other half. So in the second part, we have the initial velocity as 0 because the ball stops before coming down. And next we know that the ball needs to come down 4.05 meters to reach the ground. So that is the displacement of the ball. And acceleration is plus 10 meters per square second. Because g is downwards and ball is also moving downwards. Similar to first part, we can consider the time taken in the second part to be t2, and we need to find the value of t2. We have the values of u, s, a, and we need t. So we can use the equation s is equal to u plus half a t squared. Let's plug in the values. S is 4.05 meters. U is 0, a is 10 meters per square second, and t is t2. 0 into t2 is 0. And we can interchange LHS and our HS so that we can keep the unknown t2 on LHS. So we have 5 meters per square second into t squared is equal to 4.05 meters. We can send the 5 meters per square second to the right side, which will go and divide there. 4.05 by 5 is 0.81. So we have t2 squared is equal to 0.81 seconds squared. If we apply square roots on both sides, we get t2 is equal to 0.9 seconds. Now the total time taken for the journey of the ball is simply t1 plus t2. So if we put in their values, we get total time is equal to 0.9 seconds plus 0.9 seconds. Notice that the value of time is same in both the parts. This is a very important thing that we need to remember. Whenever an object is thrown up, whatever time it takes to go up, it will take the same amount of time to freely fall down. So the total time is 1.8 seconds. Therefore, this is the time of flight of the ball.